Hello everyone, let me introduce myself. My name is Deni Puritasari and I'm come from Research Center for Structural Strength Technology, Green. And today I will present my paper. The title is Comparison of Lighting Simulation Tools with focus on daylighting for sustainable building in tropical climate. The introduction and the problem of this research is Indonesian artificial lighting consume significant amount of electrical energy in residential building. It's about 26%. And this is because of a single family attached house with one side opening. And this kind of house is a majority housing in Indonesia. Plus the small window opening in that house that make house is dark and humid. This is why most of this house is using artificial light during day and night and consume a lot of energy. So how is the solution for long and narrow layout? Since Indonesia is a tropical country with a year-round sunny climate, why we cannot save our energy from lighting and collect the daylight as much as it can? Moreover, calculating the sun for the daylighting, it's quite complicated. So it's focused on building design that's sitting with the sun. And since sun's also difficult to predict, usually designer use building energy performance simulation modeling to analyze and calculate how much light that can enter to the house and can use to everyday activity. However, the problem now is there is a lot of simulation tool, lighting simulation tool, and we most of us are confused which one is better, especially for tropical climate, since most of these simulation tool were designed in Europe or in USA. In this research, we would like to analyze a simple room, and it's assumed like a living room in a simple house, and using three different simulation tools. First is dynamic daylighting, second Felix daylight visualizer, and the third is rhinoceros grasshopper. For dynamic and Felix, it's open source and it's free, and we can download it free in the website. And for Rhino, we should buy the license for this tool. The variable that we use is national standard about lighting in the housing, and the second one is weather data, and we choose Jakarta as a represent for this simulation. First analysis in dynamic daylighting, we can find that it can use for calculate a simple rectangular room, and it's able to calculate fast with beautiful beautiful result. However, the disadvantage of this simulation tools is limited only for rectangular shape and rectangular window. And the second one is Velux. It's more complete than the first one. It can provide the detail interior, and then rendering. Also, analysis can be illuminates and luminance. And then, however, the weakness of this tool is we cannot detail input the weather data of the building. So this make one problem because we locate in tropical climate, and uh, our location is unique. Not all the time we get the sunlight, but still have a cloud and other things. And the last one is grasshopper. Grasshopper is more complete than these two building, and it can produce a lot of analysis results from the illuminance, luminance, daylight factor, and other things. Moreover, the conclusion is if you want to use dynamic daylighting, it's best for simple shape and simple window, and then only limited to rectangle shape. However, it's already used detailed weather data location, so we can use as an early prediction for our design. And the second one for Velux, it's more suitable for residential building, and it's better that we use the first simulation tool first and then continue the rendering using these tools. And it's an open access and simple to use. And the last one, if you have more complicated design and then you need to analyze more complex building, grasshopper, rhino, it's more suitable for analysis. So in the end, that choosing the best simulation tools will directly affect to your energy consumption, especially in tropical climate. So for tropical for early stage, it's dynamic lighting is suggested, and then for the interior using Velux daylight. But if you have a complex residential building, grasshopper rhino is recommended. So additionally, a more detailed and accurate tool performance evaluation will complete the validation is needed. Access to accurate and user-friendly simulation tool could increase the use of performance based on evaluation and design. Thank you for listening.